Hi, I'm Tom, and in this video I want to show you two Matter dimmer switch projects I've been working on. The first is a touch-based dimmer switch, and that's running on an ESP32H2, and the second uses a Rotary encoder, and that's running on an ESP32C6. Both are built using Espressif's Matter SDK, and the two dev kits I'm using are from Waveshare. All the code I'm using is up on Github, and I'll include links to both of those repositories in the description. Let's start by taking a look at the touch-based dimmer switch. This is an ESP32 H2N4 dev kit from Waveshare. Now, the H2 variant of the ESP32 doesn't include any Wi-Fi modules, so this one is currently using Matter over Thread. Off to the side here we have an Adafruit AT42QT1010 capacitive momentary switch module. These capacitive switches are quite interesting in how they behave. When they get powered up, they create a small little static electric field over this panel, and when you bring your finger in to touch them, you essentially disturb that static field, and the device then will register a touch down this blue wire. In the case of my Matter switch, that will fire an on-off toggle command. To show you this in action, I have a Matter nanoleaf bulb set up here. This bulb has been already added to my iOS home app, and I can essentially turn it on and off from here. You'll also notice that my touch dimmer and my rotary dimmer have also been added to iOS Home, but unfortunately iOS Home at this stage doesn't support light switches or dimmer switches. To work around that problem, I've had to use the Matter chip tool to bind both of my dimmer switches directly to the bulb. I've made a video on how I've used a Raspberry Pi to do that, and I'll include a link to that video in the description if you'd like to find out how I did it. So with our switch all set up, all we need to do now is tap, and we can see that the light turns on, and we'll also notice that that's registered in the iOS Home app. And if I tap it again, the light will turn off and it will register as off in the iOS Home app too. But I've said that this is a dimmer switch. So if I turn the light back on and I bring up the dimming controls, if I now tap and hold, we should see a change in the brightness. So the light is beginning to dim. You can see that reflected also in iOS Home. And if I tap and hold again, the bulb should start to increase in brightness. And you can see that happening there. Pretty cool, huh? Now, I'd like to take this one step further. Now, on this Adafruit breakout board, there's actually a small terminal there, which allows you to connect to an external surface that you're going to use to hold the static field. Now, what I've done is I've connected a blue wire to a piece of copper tape that I've simply stuck onto a piece of cardboard, and that will now act as our external surface. So what I need to do now is recalibrate by powering down and powering back up, and that will allow the breakout to establish a new static field. And if I tap this, the light will turn on, and if I tap it again, the light will turn off, and the same behavior will work for holding it down. And we can see the light beginning to dim. My plan is to install the copper tape under a small side table that's beside my couch, and I can connect it up then so it will allow me to turn on a floor lamp simply by tapping the underside of the table. So that's a look at the touch-based dimmer switch. Now let's move on to the rotary-based switch. For this one, I'm using an ESP32 C6N8 dev kit, which is also from Waveshare. Similar to the H2, this module also includes Wi-Fi in addition to the Bluetooth Low Energy and the thread radio. The rotary encoder I'm using is an HW040. Now, rotary coders work by generating little pulses every time they're rotated, and that allows the receiver to determine the speed, the rate at which it's being turned, and also the direction in which it's being turned. Unlike a potentiometer like this, which has bounds as to how far it can be rotated, a rotary encoder has no such limits and can be rotated forever. This makes it a much better choice for things like dimmers. The potentiometer would work perfectly well, but let's say I adjusted the brightness down to 0, so I rotated it all the way in one direction, and then I used my phone to adjust the brightness back up to 100%, I'd no longer be able to dim because I've reached the limit of the potentiometer. In addition to supporting rotation, this particular rotary encoder can also be clicked, allowing it to act like a momentary switch. Like the touch button, this has already been bound directly to the light bulb using the chip tool, and I can now use this to turn the light on, and I can adjust the brightness up or down and then turn the light off. For this particular device, I plan on adding a couple of more rotary encoders into the mix. I'm hoping to have 4, maybe 5 in total, and I'd like to then install all of them in a small decorative box, which I could essentially keep on the coffee table. That would then give me quick access to the different lamps and overhead pendant in the room, and it would also allow me to control the lighting in the adjacent room. And for this, I'm kind of thinking of my sitting room, which is connected directly to the kitchen. So it'd be nice to be able to, say, dim the kitchen lights or switch them off if they were on, and then adjust the brightness of lamps or switch off the overhead pendant, for example. Ultimately, I do plan on using Matter over Thread for both of these devices simply from the point of view of power consumption. Matter over Wi-Fi is great, but it's far too power hungry for battery powered devices. Saying that, I still have lots of work to do on the code in terms of ensuring that the power consumption is very low. For example, the capacitive touch module that I showed, that actually draws power because it needs to maintain the static field, and it also has to be watching for changes in the static field. So I do need to see how power hungry that particular board is, and if it's a bit too greedy, I may need to look at alternatives. I also need to improve the behavior of the dimming. As you'll have noticed in the demo, there's quite a long lag between holding the touch down and the light actually starting to dim, and that's about 5 seconds at the moment because that's how it's been configured. So I do need to play around with that and see if I can use maybe a curve kind of approach, or if I'm holding it down for longer periods, it'll rapidly brighten the light or something. So I need to play around with that just to try and improve the behavior. As I mentioned at the top of the video, all the code for both of these projects is up on Github. So feel free to pull it down, compile it, install it, and have a play. If you have any questions or need any help getting anything up and running, please do get in touch using the comments. Hopefully you've enjoyed this video. If you have, please do click the like button, as that helps the algorithm promote the video. Do check out some of my other videos, and if you kind of like the kind of videos I'm making, please do consider subscribing. Otherwise, that's it. I'm Tom, and thanks for watching.